studies. I'll start a little bit about me so that you understand who's talking. I'm not a maritime guy, and I wanted to present that in some way. Also, I will you will explain what's the webinar objectives. What are you expecting to learn? Start with a little bit about autonomous vessels and show you what's the current state of the art. Tell you a little bit about my perspective and my research so you understand the scope and what I have covered and what I didn't. We discuss a little bit about the communication aspect from what I have seen in my research, the cyber risk management. I will conclude with some final remarks and then present the lab that we are having here in NTNU, where I work, and discuss some future direction that hopefully will open some room for collaborations. I was born in Emirates, and I lived most of my life in Palestine. I do not have access to the sea in Palestine, so for me the sea was something that I don't see every now and then. In Emirates, I was young. We had a really good marine life in Emirates, but I was very young. But in Palestine, where I grew up, we didn't have access to the sea. So for me, ships was something that I know about. They exist, but I didn't actually get a chance to get into a ship until I came to Norway. And my PhD was in autonomous vessels. So I was like, there's a word that is called maritime. I was like, I searched Google, like, what do they mean by maritime? So I started my study. In my education is in computer engineering, and in my master degrees in Saudi Arabia, it was about security information assurance. So it's mostly IT. And in my work, also, I had a very extensive experience in IT as well as a network and security administrator. And only in Norway, I get to learn a little bit about maritime. So when I will explain to you from a computer engineer perspective, a computer science perspective, that got to learn a little bit about maritime. So be critical of that aspect and feel free to ask me anything that I might have missed when I present my work. In this webinar, we will talk a little bit about autonomous vessels and how is this the current trend. You will learn a little bit about the maritime cybersecurity from my perspective in autonomous vessels research. I learned a little bit also about maritime cybersecurity. I'll discuss some challenges that I have faced during my research, some threats in the domain, and some solutions and approaches. Also, I'll discuss some future directions that we can work together on. Let's start with autonomous vessels. And what I mean by autonomous vessels in this regard, which is the official category that's called Maritime Autonomous Surface Ship, which is a MAS. That's how International Maritime Organization defines it. I don't look at underwater vessels. I just work on this type of vessels. And it's defined in my PhD as a ship that has some level of automation and self-governance. And those levels are defined by the International Maritime Organization as 4 degrees, from mainly manned to totally automated. And the autonomous ferry that I have worked with will be in the 4th category, and I will explain it. There are examples of existing ones that are live and operational. One in Estonia. I'm sure most of you have seen, heard about Mindship from Hugo. They're really good people. We're working with them on several research projects where they develop multi-purpose vessels that can be worked for cargo, for scanning, for many others. And in Norway, we have the passenger transport, Milliampere 2, which I will discuss mostly in this presentation. We have also cargo transport, Yara Berkland. And in Sweden, there's the MFS TEL, which is built by the same company and researcher that built Milliampere 2. So that's it shows that the technology is expanding. I'll talk now about my research so that you see what have I focused on. The motivation that drove me into this research, focusing on the communication and cybersecurity particularly, is that I expected at some point in the future that some news might break that say that a passenger ferry is hacked and led to collision. Some passengers are injured, so there is a safety issue of critical level. Although this is fake news, it didn't happen, just to be sure, but the statistics show that it can happen. This is just a statistic in 1 year in Japan that shows the amount of marine incidents that can happen in the domain. Although none of these, just to be clear, none of these have been linked to a cyber incident. None of them. But it can happen. It might happen. Because there are many other incidents that has happened in maritime with various types of impact. It can be from exfiltrating very critical ship designs to actively cutting the internet connection, disrupting some operations, into ransomware, some devices and softwares on board vessels. And this has led the International Maritime Organization to call a resolution for maritime stakeholders to consider cybersecurity. So my PhD and my research focused mostly on addressing this resolution and seeing how we can address cybersecurity in ships. The use case that I have focused on while doing my research is this, which is called milliampere. As part of the Auto Ferry project, we start with milliampere 1, which was a very small research vessel, half scale. Then we worked into milliampere 2, the one that you can see here, which can carry 12 passengers, and it reached a trial level. I will give you a little bit about the ferry itself. The ferry, as you can see, it's hosted on the Trondheim Canal, which has one specific objective: to take passengers from point A in the canal to point B autonomously. It should be in an elevator mode. Some passengers board the vessel, they press a button, it will find a safe route because the area is highly condensed with traffic, and it will maneuver and work its way until it reaches the other way and then goes back. So it's very simple in its functionality. But to do so in an efficient and safe way, it relies on a wide range of systems, from 5G to 4G systems to satellite for navigation and real-time kinematic positioning, which enhances the accuracy of GPS. And inboard the ferry itself, it's equipped with GPS, radar, camera, and LiDAR. All of them collect information, send them to a navigation system, which makes decision and send it to a machinery system, which makes the ferry works through active thrusters. My PhD and my research focused on how to connect all of these systems in a safe way and reliable way, and how to make them secure. That's my focus, just those two perspectives, communication and cybersecurity. The challenges that I have faced when I start, other than my lack of knowledge in the domain, of course, but the ferry itself, it had lack of legal framework. At the time when I did my research, there was no legal framework that governs the technology. So we don't know which requirements we need to abide to, what systems we need to include to address the requirements and the laws. Additionally, there was a lack of unified industrial vision. At that time, DNV has suggested some ways of building autonomous vessels. Munin, which was a European project, that suggested how to do so. Rolls-Royce also suggested their vision. So we didn't really know what systems are expected on board and what are not. Doing that, it would have led to having a communication cybersecurity solution that are subject to change. I might have proposed something in my PhD that might not be relevant to the industry when I'm done. To avoid so, I went to my research with these two different characteristics. Having resilient, flexible, and modular architecture so that what I proposed can be exchanged and changed when the technology changed, so that it does not influence the entire solution. The another one, I wanted to be comprehensive so that I consider most of the options that all these technologies can include, as well as have continuous processes. When you have continuous processes, it means that if you change something, you can repeat the process in very little overhead. That was my main objectives going into my research. I'll start with the communication side. For the communication, the main goal for having the communication was for safe and secure operation. The vessel should operate in a safe and secure manner, so the communication should support this objective. So when I went to developing the architecture for the vessel, these aspects were considered. What operational context it will work with, in which operational mode it will operate, what are the stakeholders that are involved in this ferry, what are the requirements that needs to be addressed, what functions needed to support those requirements, and what components need to be integrated into the ferry to address all of that. So it's a bottom-up approach. Top-down approach. The operational context of the ferry On the right, you can see the model, which is the mast, the autonomous ferry in the middle of aids to navigation, ports, VTS services, shore control center, emergency control teams. So though it relies on a wide range of entities around it to operate. In Trondheim, it just works on a 100-meter route, but this 100-meter routes exist in a very busy area in Trondheim. And the remote control center is placed in about, let me remember, about 2 kilometers distance from the ferry itself. So we needed some sort of cellular communication for the remote control center. The way it operates, it's on what's called an auto-remote operational mode, which was defined by DNV, which basically means autonomous when possible, remote when needed. And it is set to enhance safety, efficiency, and environmental performance. In the auto ferry, how would this be realized? You have the ferry at one place and you have the remote control center at another, and they have bi-directional communication between them. The ferry will record the information from its surrounding, create a situational awareness for itself, and drives itself. The same situation awareness should be sent the data to the remote control center. The remote control center, using operators, will assess the situation, and if there's any need to intervene, they can remotely control the vessel from their side. That was how the operation mode can work. Then we discussed what stakeholders should be involved. I did extensive research, and there are 52 types of identified stakeholders in maritime, related to maintenance, installation, local agent, and many others. Not all of them are relevant, of course, to the ferry. That's why we cut them down to 24 and categorize them into different categories to see what are their requirements that needs to be addressed. At the end, we found a linkage between them so that we see which requirements that are needed from one another in the context of the ferry itself, so that we build a communication architecture that addresses all of these requirements. For example, the classification societies, DNV, Bureau Veritas, and many others, they focused at that time for the communication and the cybersecurity requirement. They had many others like safety, usability, regulatory requirements, but from my PhD, I focus on the communication and cybersecurity aspects. The communication requirements were divided into 3 types, such as external. The ferry needs to contact remote entities. There are requirements for the ferry itself within its network, and there are requirements for the ferry to communicate to other vessels around it. The requirements, it's not the main purpose of this presentation, but just to have an idea, some of them such as having redundancy of service, fault tolerance, having an emergency push button so that the passengers need to establish a communication with the operators in case something happened. Internally, there need to be segregated of network, traffic redirection in case their connectivity was lost. And other ships, there need to be a line of sight communication to other vessels. And there were other general requirements that are needed for the different types of requirements, such as have standardized transmission protocol, type approved component. These are common requirements that you can see in any. There are also other cybersecurity requirements that were communicated that should influence how the communication architecture is developed. And these are mapped to the NEST framework. The NEST framework discusses 5 main core functions, cybersecurity functions, and we mapped those requirements to address all of them: identify, protect, detect, and response and recover. So we found our requirements for all of these core functions. The requirements themselves are not the main purpose of this presentation, but these requirements defined what functions we need to have in the ferry, which led to then building the communication architecture, which describes how the ferry will work with its operational context. You have the ferry network at one side, you have the remote control center at one side, and when we actually built it, I was happy that my architecture was taken into consideration into developing all of these components, and we actually implemented. I was personally responsible for implementing the 5G link between the remote control center and the ferry itself. So the ferry itself was built by NTNU team and additional company called Marine Technology. And the remote control center as well was built by the two. Each one focused on a specific functions. The link between them, we had VHF link, and we had a direct link, which was a proprietary link, as well as 5G. I'll discuss the communication challenges in this presentation. In bottom line, 5G failed. It really didn't do what we had originally anticipated it to do. We had a trial period for almost 3 weeks for the ferry, which was open for the public. They went into the ferry to test it out. And we wanted to see if we are able to send the the situational awareness data from the ferry to the remote center. But if you can see, it might be hard to see in your way, but basically the presentation shows this slide shows the amount of data that was attempted to transfer from the ferry to the shore, and it was a lot. So the first part of the trial, we had really a big spikes of data that was trying to be sent to the remote control center, but it was huge and it didn't arrive at a good time. Because we had LiDAR data, we had video data, we had so many information that wasn't really efficient to send over the 5G. On the next part of the period, the trial, we reduced the essential data, which is just the sensor data, not the video, not the LiDAR data, just what's needed for basic functionality for the remote control center, and it stabilized the network. So that was the first challenge. The other challenge regarding the coverage, the 5G did not operate all the times. And this is very hard to anticipate. The ferry had both 4G as failover and 5G as main connectivity. But due to the network coverage, the 4G was the main one. So the network, both the ferry and the remote control center did not meet each other at 5G link. So the speed was degraded to 4G link. And so the summary basically that it was not clear what data needs to be sent to the shore, how to do it efficiently over 4G or 5G, because we had a lot amount of data that needs to be sent. But after time, we discovered that we don't really need to send them all, only maybe send some specific amount of data to the remote control center to make specific decisions, but not all of them are needed. The 5G was not utilized as anticipated. The 4G was the main one that was utilized. Also, what is a bit, I would say, funny, that it was planned to be an autonomous vessels, but at the end, we could not run it autonomously. We needed someone as a safety operator to be in the ferry in case anything happened, because the remote control center was not operating function in a good way. Someone needed to be on the vessel, which is okay for now for research, but the future that goes against what was originally planned. Now we start with the cybersecurity. Now we have established the communication architecture, the ferry works. What are the cybersecurity risks? I will first describe what I mean by cybersecurity in contrast to information security, in contrast to safety, because this distinction I found to be very important. Information security will focus about the data itself, the integrity, the confidentiality, integrity, and availability of these data. These three properties are the most important for information security. In cyber, it's different. Cyber, we focus on more than the information itself. We focus at the system itself. An attacker might be in a system, not doing anything on your data, but his sheer presence on the network is a problem and needs to be addressed. It does not influence the data or the information, it influences the system security. So the cyber focuses on more than the information, focus on the system. Safety and security also is a different constructs. Safety focuses mostly on the influence of the system on its environment, such as hazards, maybe fire, maybe electricity. On the security, we focus mostly on the malicious influence of the environment on the system. So if you have an issue on safety, let's say on a vessel that something failed, just maybe go to manual operation, try to replace it with a different system. So it's a natural accident. Security is different. So with cybersecurity, there's a malicious intelligent entity in your system trying to do harm to you. So it's replacing, cutting down. Then the one system might not be enough. It might be the malicious entity might be in another. So it's a different mindset, different types of hazards, different approaches to solutions. Risk management is the process of how to manage all of these risks. And cybersecurity is usually done through a risk management process, which includes risk assessment in the middle of it. You identify the risks to your system, you assess the likelihood, consequences, and calculate the risk value. This process is very time consuming. This is the most observed thing. This is usually done using human, and the human identify the risks with their intelligence and experience and do this risk assessment in a periodic manner. And it's time consuming and takes a lot of time, and it's not always comprehensive, and it's biased most of the times. So my approach to this issue, since the autonomous ferry will change in time, a lot of components will come and go. The life cycle is very short. And since it's novel, it will be updated continuously. Doing risk assessment all of the time will take a lot of effort. And to visualize this issue, I'll tell you in my risk assessment how it's observed. You have a cyber physical system. That's how I modeled the vessel as a cyber physical system. You have a threat landscape, and you have cybersecurity strategies to consider. The cyber physical system is constituted of a group of components that are linked to one another, and an operator, a human element that is sitting there. The threat landscape, you have tactics as attackers' objectives, you have techniques, attackers' methods, and you have procedures or tools. This is how usually the threat landscape is modeled. And in cyber strategy, you have a group of mitigations across different defensive layers, such as physical security, network security, host security. And the system goes through a life cycle. You have design cycle, implementation, maybe an operational phase, then you might take it to maintenance, then another operation phase, and so on and so forth. While the system goes into this life cycle, it might have a new components, changing configuration, changing functions. The threat landscape itself, you might have new threat actors coming to force. You have new cyber attacks. You have new vulnerabilities coming. And the cyber strategy, you might have a new policy. You might have new solutions, and you might have a change in budget. There are many variables. And at each variable, you need to do a new risk assessment. So imagine doing a very comprehensive and expensive process every time you have an update in your system. That's why I proposed a semi-automated risk assessment process, so that you can model the system, run a semi-automated process to identify the risk in your system, and gives you what are the most needed mitigations. I'll not go in depth in this process. I will focus on how I made it less human intensive. I relied on existing data sources for collecting the risk information and the threat information, so that if you can see here, the blue line represents what is needed from experts, what information are needed from experts. The red ones represent what can be extracted from existing threat information. So running this process continuously will reduce the human intervention. And it gives you comprehensive results. A huge amount of risks are considered to each system, and it gives you a huge amount of mitigation measures that are important for your system. What types of risks are considered? There are 16 types of failure categories, and I will give you an example, and almost 736 types of failure mechanisms or attacks. For instance, initial access. Attackers would like to gain access to your system. What are their techniques to do so? What are the mitigations against it? Attackers then would like to discover and collect information from your system. You have also mitigations against that. Attackers would like to exfiltrate data from your system, and especially the auto ferry. It's a new system with a high novelty. So the intellectual property is extremely high. So attackers gaining access to autonomous vessel might gain a really good strategic advantage in the market. Also, command and control. The autonomous ferry rely on communication a lot. There are traditional vessels as well, but autonomous vessels rely also on 5G and a much faster communication. So attackers can really communicate with the vessel remotely. And I will provide an example of how I discovered that. Also, attackers would like to do impact to your vessel, either collision, denial of service, or manipulation or loss of control. Since the ferry relies on sensor data, attacker can manipulate it to maneuver it and move its positioning. Then after you discovered the risks in your system, you need to apply a security architecture or a defense strategy, let's say. And this is usually done in a layered approach, what it's called defense in depth. Defense in depth basically means distributing the security controls at different layers, from physical security, perimeter security, until you reach the different layers, including vendor management and training. So I proposed a process as well. This is time consuming. This is very time consuming. So I proposed a tool that you can encode your information of your system and your defensive security, and it will give you what is the optimal security architecture for your system. I'll give you an example. I don't know if you heard about BIMCO guidelines for cybersecurity. You might have also heard of DNV guidelines for some class guidelines for cybersecurity as well. All of these can be encoded as security strategy. What needs to be, what controls you need to have and what controls you don't need to have. All these have been modeled in my tool, and you can run in your system and to identify which one gives you the highest risk reduction. And you can then choose to move forward. Then when I chose a specific security defense strategy that aligns with with the goals in the project, we went to each defense layer to apply it, starting from the network. At the network, you need to do usually segment it into different segments. And I found a challenge in that regard, because the standards in doing so usually do not consider having a remote operation center. Usually the control function needs to be in the same place as the controller system. So having a remote control does challenge this architecture. Then firewalls, you need to integrate access management, you need to integrate intrusion detection, as well as security incident and event monitoring, and VPNs. All of these have been implemented into the Ferry, and then we have wanted to evaluate it. There are many ways to evaluate the cybersecurity in maritime, and I did a systematic literature about that, such as risk-based evaluation. You calculate the risk and you implement controls, and you see if the residual risk is sufficient or not. You have simulation, gamification, unit testing, and sometimes on the vessel itself, and sometimes on simulation. I did 3 types of evaluation on the Ferry itself as well as in a simulated model. The simulated model, I created a complete replica of the ship network as a simulated system, and I ran many attacks to see if they can work or not, and then improve the security of the vessel based on this simulation, which is a very common approach. You don't consume a lot of resources on the vessel itself, and it's safe. If you messed up with a very strong attack, it's just simulation, you can restart it easily. Then I went to the Ferry itself to do a complete penetration testing, where I found very interesting things and how this Ferry operates and what are the challenges, security challenges in that Ferry. I prepared a comprehensive plan of tests to do. Some of them were possible to run, others were not because of access controls. Some systems are not supposed to be within the scope of penetration testing to the vendor policy, so they were kept out of the penetration testing. But still, I found three crucial vulnerabilities that needs to be considered. So my approach was very comprehensive. This is the thing that I wanted to say. So whenever a new autonomous vessel or a new technology comes to mind, most of these techniques and these attacks will still be relevant because they rely on the technology and the operation, the way that the system is connected. You have a remote control center and you have the Ferry. They must have a communication link between them. This is a vulnerability that will always stay. I applied the same process to the traditional ships, not only autonomous ships, with traditional systems such as ECTIS, GPS, gyro, MFD, Navtex, and everything. The same process was applied, and we were able to identify many risks as well into a specific model of an integrated navigation system. Of course, to do it on a real ship, we need to do it with more details on the ship itself, but we took a generic model of a traditional ship And I did this with a marine engineer, so his contextual information of the maritime domain really helped improving this process. Okay, so now while doing this new process, I discovered new attacks and defensive measures. And I will go over them quickly. Most of these focus on the navigation data. Because of the autonomous aspect of the ferry, it relies on navigation data to make decisions. It's data-driven. So it makes absolute sense to focus on this as an attack vector. The first one would be reconnaissance. I asked myself a question. The ferry needs to send its navigational data and sensor data to a remote control center. If that's not protected, anyone on the internet can see that data. So I checked, and I will give you the rationale behind my thought. You have marine components such as vessels all over the world. They're sending their physical properties such as location, speed, heading, and time to many marine tracking services such as marine traffic. This is done over the internet, which creates a cyber property of the same vessel, such as IP address, service, data, and thus vulnerabilities. And this is captured by internet-wide scanners, such as Shodan and Census. So my question was, would I be able to link an IP of a vessel because it's sending this data to the physical location of the ferry, to the vessel, and find vulnerabilities that can be remotely executed? So I did this process just to check, and I used Shodan to find that. And I was able to find around 380 ships that are setting their location. And I validated that these are ships because of their location on sea. And I was able to find from specific messages, because these messages are proprietary messages, you are able to identify the device that's sending these messages. And these devices have specific vulnerabilities. So I did not move forward. This demonstrates that attackers, just from their internet access, they can find IP addresses of vessels. And this is a demonstration of IP addresses of these are devices that sending their AIS and NMEA data, which is the sensor data basically, and they can be found on the internet. And I did that just from my laptop. So it's possible. Still, it might not always mean this is a vessel. It might be a gateway. It might be a hub connecting all of IP addresses, but this is easy to validate. But that was not the objective of this. But as a reconnaissance aspect, it is possible. I have found previously a concrete vessel. I found its location, I found its IP address, and I found its vulnerabilities on that vessel. So imagine attackers can do things. Hopefully it will be protected. That's the hope. Okay, then imagine an attacker find a vulnerability, they are there. Can they remotely communicate with a vessel in a covered way so they are undetected? I wanted to see if AIS can be done for this objective. And AIS, I'm guessing most of you know what AIS is, but for those who doesn't know, if someone's remotely joining us, it's a system to share communication to share communication data between vessels, such as safety data, as well as location data for collision avoidance, search and rescue, and many other functions. I wanted to see if attackers can actually use that to share data in a covered way. So I created a real network between an attacker AIS, a victim AIS, and the victim AIS is connected to an ICDIS through serial link. And I sent an encrypted command, and this command is expected to launch on the remote machine. I encrypted it. I added it to the remote to the attacker ICDIS, and it received the victim ICDIS, and it got executed. And I will share a video of this setup for you to gain additional insight. Just if you can confirm there's audio. Is there audio?
No, we can't hear it.
Okay, I will narrate. So we have, let me just stop and mute it. Okay, so the setup of the environment. Okay. The setup, we have the ICDIS, which is a Windows machine having OpenCPN at that time, connected to a victim ICDIS, which is MTRAC Class B AIS, and you have an attacker AIS, which is MTRAC Class A. The MTRAC Class A can send binary broadcast messages, So I created a message with a command and encrypted it using a specific encryption algorithm. And when I sent it from the AIS, the attacker one, a malware on the vessel is able to silently read all of messages, decode them, and identify a command. In this case, I just want to launch the calculator app. This allows attackers to remotely launch commands on the vessel, and they can even update their attack arsenal with a new malware. The second part shows how I can send files through this link. So attackers can initiate a file transfer command. It will tell the ECDIS, the remote ECDIS, the victim ECDIS, I'm sending you a file, please fill it for me. And we'll fill this file using AIS messages. And the ECDIS will fill this file using, which will become later a malware, which will be executed. So if a vessel is on the sea, it does not have internet connections, attackers can do this over VHF. So they can actually launch a command on the vessel, and they can actually install a new malware. And this, in this video, it shows how I was able to create a file just using from this remote AIS, and the file was created on the ECDIS. And this is how usually malware is created. You create a new file, and then you launch an execution command. Okay, now attackers have the ability to communicate with the vessel covertly. What else can they do? There are different ways that you can impact a vessel operation, and one of them is the navigation data. So to test what needs to be done in this regard, we created a simulation environment where you have a ship sending its navigation data to the ECDIS, and this is usually done through a protocol called NMA. That's how most marine components communicate with one another. It's in plain text. It's not encrypted. It's not encoded. It's open to many attacks. So what I wanted to create rules that will say that someone has did this. So I tried many messages with many fields, and I did many attacks, such as changing the speed of the vessel, changing the location of the vessel, doing it in a fast step, doing it a small step, doing it gradually. So our environment creates the ability to do many types of attacks. This will create signatures so that you can detect it as intrusion detection. So the more comprehensive you are with your attacks on your system, the more you are resilient to attackers' behavior. That's the main objective of this. And there's a video I will skip. Basically, the video demonstrates how I can drop the radar data from the transmission. If you're interested in seeing this tool and what we can do, we have in our lab the ability to do this remotely. So in conclusion, the Ferry, the autonomous ferry as a technology, the APS here is the autonomous passenger ship. That's how the main term I used in my PhD. Demonstrated success. It works. It did work on itself. It did not work for remote operation, and it needed someone to be actually present in the ferry, but it actually worked. People liked this technology. They used it, and it was very stable during its trial period. The security of it has been improved. In my research, we found that existing solutions, in addition to the ones that I have proposed during my PhD, does improve the security of it. So it's not as risky as we originally expected. There are security controls that can be integrated to make it secure, such as doing risk assessment, firewalls, updates, backup, and many others. Still, there was challenging, especially to remote monitoring capabilities. Due to the risks that were discovered and the limitation of the communication, there was a need for a safety operator. This is a very concrete result, that we were not able to do completely autonomous operation in a safe and secure manner. So there are some rooms for improvement. Everything that I've done during my research has enabled us to do a cyber physical security lab in NTNU here, where we have a group of marine components such as AIS, GBS, NMA network, as well as simulation capabilities. And we were able to create all of these attacks that you have seen. This lab, if you are interested to see it, you can check it. It's in NTNU homepage. It's part of the Norwegian cyber range. We use it for research, and we use it for education to demonstrate attack and defense scenarios. We have a composition of real devices as well as virtual devices, which was really good to make the research relevance data relevant to the actual environment. And we have on-premise and remote access. So if anyone is interested to test some of this lab functionality, feel free to reach out. We're also what we did, the lab that we have is in NTNU Gjøvik, which is part of Norway, just 2 hours above Oslo. The Ferry and its remote control center were in Trondheim. So I was at the beginning going back and forth between Gjøvik and Trondheim until I established a way to work most of my research and security and communication testing from Gjøvik, which now we have a stable link between NTNU and Gjøvik and Trondheim, which allows us for many remote operations and many remote testing and research. We also have a simulator in Ålesund, which is a full bridge simulator from Kongsberg, has a fully functional ECDIS and radar and many other devices, which we're able to use for security research as well. We have also cloud instances that you can test some of these attacks in cloud environment. And if at some point in the future, any additional lab facilities that you want to integrate and you want to use some of our lab facilities, we can extend our connectivity with any other organization. Taltech is one candidate that we started working in this direction, but we stopped at that time because my PhD finished basically. But hopefully we can continue in the future. What are the future directions that are of interest from a cybersecurity and communication aspect? Remote operation centers is a big deal. Like it's one of the plans of the existing maritime industry in Norway is really interested in seeing how we can do remote operations. As in the small projects such as the Ferry, we discovered that we cannot do it fully autonomous. We needed a human present on the ferry. But imagine what else for bigger ships, huge ships, for fleets. How would you do a remote operations center? What functions you need to have? Where will be the security? Will be it's on the ferry or the ships, or it will be remote? Will it be hosted in the company or externally within the existing regulations? So there are many questions to be asked. The human element, although it's autonomous vessels most of the time, but there's still a human element. How many vessels can a human take care of? Some said 6 at most. You cannot take care of more than 6 autonomous vessels. This is one research aspect. Distributed cyber ranges. Marine components are very expensive, so it can be good to share them. So if you have a marine component that you're open for research, I can allow access remotely to that marine component if you have a specific test that you want to run. And it can be done like that. Next generation intrusion detection. There are many sensor data, types of sensor data on board the vessels. I've seen NMEA, I've seen AIS, I've seen LiDAR, I've seen radar. There are some use acoustic systems. All these also can be subject for cyber attacks. To doing intrusion detection all of these is something also important. Digital twins also is another new construct in research and in manufacturing that also can enhance cybersecurity, as well as what's the security of digital twins. If there's a ferry or there's a ship that you want to test a new update, instead of doing it on the ship itself, you can have a digital twin of the ship and test your update there. Cybersecurity certification. Again, it's a very time-consuming process, and compliance with security regulation is very expensive and time-consuming. How we can make it better. And this is what I'm currently doing, not in maritime context per se. Also, Mindship, which is a Estonian company, is part of this project, but we focus on other fields as well. How to make cybersecurity certification cheaper, faster, using artificial intelligence. Threat intelligence is another aspect. There are many types of threats on cyber threats that are coming from all over the place. How we can make it efficient. Currently, mostly humans do this. How we can automate this process and reduce the human involvement to make them focus on more important tasks. Artificial intelligence, there's really no need to say why this is important. It saves a lot of time, and you can imagine what possibilities can be added to support security and many other directions. Thank you, I'm done. Maybe a little bit short than an hour, but I hope this has been sufficient. I'm open for questions now.
Thank you so much, Ahmed, for your very interesting and insightful presentation. And I'm pretty sure that we will have questions. At the moment, I can't see raised hands. But yeah, Inga would like to ask something. Inga, please go on.
Hello to everyone. Hello, Ahmed. Thank you very much for your presentation. I'm sorry, I will not put a camera because it's not working on my cell phone. And the question is that, as I understand, that much information is important for navigation in real time. And for example, electronic navigation charts, they go over to the S100 IHO standard, what includes the more precise information, additional auxiliary information on bathymetry, wind directions, waves, and everything like that, etc., etc. How these attacks could be prevented in real time, and how they could be even evident to the a person who is navigating, and who could assess that there is the data are really suspicious, and just apply any mitigation measures just in really short time. Thank you very much.
Yeah, thank you for your question. Yeah, this S100 was also another protocol that was considered. It wasn't applied on the Ferry. That's why it was kept out of scope of my research, but I'm aware of it. And it was considered as one of the aspects that needs to be considered for intrusion detection as well. But when you consider risks of a system, there are different types of risks, and it will differ between different companies and different use cases. Because sometimes you don't consider internal actors as a risk. So it's if you have a good perimeter security and access control, it should be enough. Others would consider access control as an issue because they might, like, let's say, have an international or multicultural team that trust is not something that is inherent in the work. In Norwegian culture, trust is a big thing. It's embedded. So when you say about cybersecurity, they say, okay, we just have good access control and we're fine inside. So you work mostly on the perimeter security. In other cultures, I found that access control on itself is not enough. So you need to add intrusion detection inside your system. So having specific intrusion detection that will expect certain attack patterns, for say the S100 sending the images over a specific channel, sending the auxiliary data over another channel, attackers can build attacks to target each of these channels. Images can be manipulated, images can be inserted, new messages, and it also can be dropped. Auxiliary data might also be changed so that the radar shows different types of messages or different types of alerts. And it depends on the operational context. These types of attacks will be completely different. But the good thing is that the aligning with security requirements and guidelines such as BIMCO, and recently there's a unified requirement 22, 26, and 27 by the IACS. These mostly cover all the requirements of cybersecurity. If you align to those requirements, most of the time you are safe. But always you need a specific focus. If you have a specific system that you want to investigate, risk assessment is where you start.
Thank you.
Good.
Thank you. Now I can see that Yigit has a question. Please, Yigit, go on.
Hello, dear Ahmed. Thank you for your presentation. I would like to ask you a question about your ideas about creating a digital twin of a ship on a navigation simulator. What do you think about the challenge? What are the challenges to create a digital twin of a real ship on a navigation simulator? Thank you for your answer.
Thank you. Yeah, for the fidelity of the navigation's data depends on the simulator fidelity is very important because the simulators that we have here in the lab, they're based on an open source software called the Bridge Command. This Bridge Command is basically a simulated GPS that is simulated to collect data from all the radar, the rudder, what else? You have also wind sensors and many others. And this is usually how it's done on ships. You aggregate the data into one device and you send it to through broadcast into the vessel. So any device in the bridge network usually sees these networks. And I have seen the network captures. I have network capture of many ships, and this is usually the way that you have. You aggregate all of this sensor data into one gateway, and this gateway sends it to the ECDIS or to the radar or many others. It's very versatile. There are different types of connectivity, but it's mostly if you have access to the bridge network, you see all of this network data. The way that you can attack those network data, in our system, we have a specific tool. We created a tool that you can manipulate each sensor data in a specific way. So if you want to say change the location of the vessel, you focus on a specific network, specific sensor messages. And you change the location, but let's say the attitude, longitude, or maybe manipulate the north, south symbols, etc. If you want to target the radar also sends its data in specific fields, such as the radar status. Is it tracking? Is it lost? The distance to target, the number of targets, things like that. These usually, when you want to protect your network, you create a Trojan detection to these fields. And you say if it got increased, let's say by very large number, immediately it must have been manipulated. In some cases, also it can be a sensor is failing. Let's say that the speed is attacked. Someone has attacked the speed of the vessel so that you can manipulate that speed. It might be that the sensor for the RPM, the rotation per minute, is just stopped sending information or it's sending valid information. So this distinction between failure and attack is also a big deal. To do it in a really authentic way, you need a high fidelity simulator or a real vessel to do that. In our lab, we use Bridge Command, which we had some challenges, and it's in our paper. If you look in our research, you will find our research there, which we mentioned limitations in the simulator itself, but it's really representative of the environment. I've checked traffic on real vessels. The network protocol, the sensor data is in the similar structure. It's very similar. So a high fidelity simulator will be enough. I hope I answered your question.
Thank you for the answer.
That's Maria.
Yes.
Hi, I'm Maria. I am here from Marine Institute in Canada. I just want to say that presentation was incredible. Like I would love to get you to come over here and do it for our stakeholders in Canada. I'll probably touch base with you after. But we have introduced a new maritime autonomous systems testbed here in Newfoundland and Labrador, Canada. And part of that will be setting up a cybersecurity lab. So that your research is very relevant for us as well in the Canadian context. My question is, you obviously have your IP addresses on ships, the AIS signals. You have actors that can manipulate that, as you have shown us. And if you have software on these ships that detect intrusion, and oftentimes if you've detected it, it's often too late. What is the response once a ship has been compromised and has been altered, and people are, mariners are on board, and you got students there? What do they do? Like, what is the risk response to these attacks?
That's an excellent question. In my thesis, in my PhD thesis, I have addressed that. I will give you a very simple, funny answer that I got when I asked that question. I was doing the penetration testing and find vulnerabilities and tell them I can do this. If I do it, what will happen? And the engineer at that time in the ferry told me the ferry will hit. At that time, because it's a new domain, they really don't know. And they still don't have a fully functional remote operation center. They have the ferry working. The autonomous aspect of the ferry to some extent is working fine. It does have some breakage every now and then, but having a safety operator on the ferry takes control of things is enough. But this is a small ferry, mind you. It's not a big ferry. It's not a big ship. So the incident response is a big deal. In Olison, in New Olison, which they focus not on systems like I do. They focus on operations. They focus on marine operations. They have a full bridge simulators where I participated in many courses that we give to seafarers, where we in that full bridge simulator we distribute different ranges from captains to cadets to many others, put them in a simulator room. We simulate an attack and we see the responses. Those simulators have full functionality. They have VHF, they have AIS, they have radar, they have everything. So they have a full range of response, and they can call someone over the phone that what's happening. You can call your company and test different responses. What we have seen that they most of the time are struck by the surprise. They're not used to these types of incidents. They mostly say that there's a failure. AIS fails, it's not a problem. But when they see an intelligent person doing something and they see the ICDIS moving in a very bizarre way, they don't know what to do. So most of our efforts now is training. We are doing a lot of training in that regard. So they are aware that this can happen and how you do. So training is a big aspect.
Do you think the response would be more manually based, like a reactive response, a manual response of doing something on the ship? Or do you think that there could be a way that we could counter the attack electronically?
It's very early to say at this stage, because as I told you, the technology is still growing, and it's completely different from one manufacturer to another. I have seen different implementations, and there are very big variance between them. But from my experience until now, technology is not optimal. So human intervention is a must. I don't see any way away from that. That's why the human element is a big part of our research.
Okay, very interesting. All right, thanks so much.
You're welcome.
I can't see him now. Okay.
Gabor.
And Gabor.
So, okay, Gabor. Yes.
Thank you very much. Thank you, Amro, for this excellent presentation. I'm really happy that you are here and you shared your thoughts. During your research, have you ever found any good and reliable way to distinguish sensor failure or attack?
Yes, I would say that I haven't. I have approached to the borderlines between them. Usually what to do to actually distinguish that, you need historical data. And what I mean by that, we have a simulated environment that we are able to run bridge command in different simulation environment and work different routes, collect normal data. And we also used my tool to do specific attacks. And we did a wide range of attacks. And we analyzed the results. Sometimes the sensor failures can be seen. And this, what I mean by that, is an anomaly detected without an active attack running. So we are able to see how would sensor fail. For instance, the sensor for the depth showing from 100 or 200 to 0 immediately. This means that the sensor got failed. Can this be an attack as well? It can be, but why? That's the question. So there are very important need to see the attacker's objectives. It need to be understood. What do attackers aim by targeting this specific sensor data? If let's say they addressed the wind sensor, and the wind sensor is very crucial to the ship movement function, then it's high possibility that this attack. Even if it's not an attack, there should be some sort of a response. And history does tell you. And one aspect, I think it was also yours, which it's good to remind that having different sources of sensor data, that's also a very important aspect and can tell you. So there's no definite answer in that question.
Okay, thank you very much.
You're welcome.
So, Ahmed, please. Do you have a question?
No, anyone? Okay, Ahmed. Go to me.
Okay.
Well, you're muted, I think. Cannot hear. Still. Have we lost him?
Okay.
Do we have questions among the colleagues who are in the room?
So, okay, we have one question here.
Okay.
Saima, yes, please.
Yeah, actually, as we lost Ahmed, thanks, Ahmed, for this nice presentation as usual. Actually, I have a question for you about your penetration testing plan, because I can see that you built it based on Mitri, and actually we did a similar penetration testing based on Mitri as well. But I like that you did the plan, like that you have put some scenarios somehow, like how you are going to test it. And I wonder how, like, which kind of database, or it was based on your experience, or like how you got such information. And if you have published the paper, I would like to have the paper name so that I can read it. Thank you.
Yeah, thank you for your question, Shema. As you're mostly with your research in threat modeling, you understand that MITRE is a great model of threats. You can use it to model threats, and that's what I basically did. I used it as a way to model the threats. So I then modeled the tests based on that threats. So no, it was based on my experience. I'm a certified ethical hacker, so I know how to do penetration testing, and I brought my experience in the domain into doing that. Yes, the paper is published. It's in my Scholar page. It's I will share. I have your email, so I will send I'll send it to you. So I don't assume that it's complete, and it might need to be updated, but it was really good, and it linked to my risk assessment. So I discovered those risks. So I built a test for each high risk in each category of MITRE attack tactics.
That would be great to share it, because actually, you know, I'm also a certified ethical hacking, but I'm not doing the tests myself. However, still, when I check, there is a big difference between, like, when you think about firmware penetration testing and like wireless penetration testing. Normally, the experience is mostly in the web and the network. So this is the reason I'm asking, because I think for the web and the network, we have enough resources. However, there are some gaps when thinking about cyber physical systems. So yeah,
Indeed.
Thank you so much.
You're welcome.
Maybe Ahmed can try now.
Can you hear me now?
So, yes, Ahmed,
Ahmed.
please.
Okay, I'm using Linux. Sorry for that. So, and the question is, currently my research is about the development of a maritime security operation center, and I was wondering if you can give your opinion about it. Do you think it is a proper approach to the ongoing development of, or the digitization of maritime as one centralized location, that we can look into it and also be like our testing environment, that we can know what kind of attacks that can happen in one place in a certain company or a certain location in the world, which can help us identify threats and how to negate it or mitigate it.
Yeah.
And thank you for your presentation. It was really eye-opening.
Excellent. I'm happy to hear. Yeah, regarding remote operation center, I have studied that in my PhD. Although it's in the auto ferry case, it's, I would say, irrelevant, because it's a very small ferry. It has one remote control center with limited functionality. But at a high scale, you have, let's say you have a fleet of vessels, 100 and more than 100. Then an operation center becomes very crucial. And there are research on that. I can share a paper that they have actually built a test shore control center for cybersecurity specific, like a SOC, a remote SOC. And they tried to test it with existing solutions to see what are the limitations. And they found that doing a SOC in a maritime requires a completely different stack of solutions. Although IT is very easy, you can integrate IT into a SOC easily. But you have many maritime specific systems and many maritime specific tools that you simply do not catch cybersecurity threats using traditional solutions. Such as if someone targets the enemy messages in your network, or the S100, let's say, radar data, and you're using traditional, let's say, Nessus or traditional Fortnite. What's that Fortnite? I forgot. A traditional firewall, let's say, it will not catch this attack. So you need a different stack of solutions. So this is a domain that's still early, and I can tell you from knowing the maritime industry in Trondheim, in Norway, they don't know how to do it yet. It's not clear. It's a very novel idea, but there's a big direction to go in that direction. It's really important to go in that direction. So it's a relevant research area, but still very limited information about it.
Yeah, this is what I get the feedback from it as well. Like I found 1 or 2 papers or 3 papers about the design or the actuality of it. Yeah, so thank you very much.
Yeah, sure.
So, and Andre, please.
So, trying to switch my camera as well before. So I hope you heard me.
Yes.
Yeah. Oh, very nice. I was very enjoying your presentation. That was very nice. Yeah. Thank you very much. My name is Andrei Pridanikov, and I'm from Estonian Nautical School. So I'm quite close here to Maritime Academy. And I want to use my chance to send my warmest greetings to Elna. She was my English teacher. So if my English sounds weird,
No, it's fine.
Yeah.
Self-critique.
From the highest level of technologies, I want to, my question is a bit of about the basics. The basics of the ship handling. It's the collision regulations. During all your investigations, during all your testings of those equipment you put on board, have you met those the regulations and how to solve those problems? For example, in the certain areas, there still can be vessels without any those sensors like IS, radar, or whatever. They are not sending the signals, but they still can be presented as a maritime transport there. So yeah. This autonomous, the communication between autonomous vessel and manned vessels, how they solving those problems concerning the COREX?
Yes. It's a very interesting question, and I can tell you that in my research, I did not particularly focus on it because the ferry had a very specific operational area. It was meant for urban functionality, urban transportation. So such as the issues with the GBS or the GNSS, let's say in Brazil, or the boiler miscommunication was not a threat that I have addressed. But I can tell you from experience that for other domains, it's an issue, and they don't really know how to address it currently. There's the low orbit satellites as one upcoming solution, where they're really distributing them at a large scale, such as Starlink, and these can be used to increase the communication between the vessels. So this can be a solution, but still it's not completely perfect. In some areas of the world, still it does not work. So this will always, I think, will stay as a problem in the future. But there's an interesting, I don't know if you found this interesting or not, there's an interesting way that they're investigating in Trondheim, in TNU, where they're trying to give a voice to an autonomous vessel. So an autonomous vessel can be given a voice using generative AI. So the vessel can be equipped with an artificial intelligence captain, knowing the vessel routes, knowing all the regulations and everything. The vessel will have a voice, and they actually tested that. They started sending the data voice over VHF, and they had a VHF receiver converting text into voice into text, sending it to ChatGPT node, and it responds based on what it's trained. So this communication aspect is being investigated in many ways. In the ferry itself, in our ferry in Trondheim, there is the core rig regulation that needs to be respected. This is one of the main standards that they wanted to respect. I did not investigate how cybersecurity could influence the core rig regulation, but a student in Taltech called Mohammed Erbas, I don't know if you're aware of him, He did that. He implemented a threat modeling process that would link each core rig regulation to a specific threat. I haven't done that. It's not easy. That's why I didn't do it, basically. It requires a lot of time and domain-specific knowledge that I don't have. I'm not a marine guy, but it's a very important aspect. I would give you that.
Okay, from your personal view, what can be easier in the future? To change the regulations itself, the call regs,
Yeah.
or to adapt the IE to those rules?
I hope I can answer your question. I'm not a regulator guy, but it's a problem. I give you that.
My opinion, modest opinion, if I can come in, is that call regs will have to be changed for sure in the conditions of autonomous ships.
I'm expecting, some change will happen. Yeah.
Yeah, changes are coming. That's for sure. Thank you very much. That was
welcome.
Yeah, I'm appreciated very much. Thanks.
So, as I understand, you don't have.
I have one question.
Sonia?
Yes, I have a question.
Please.
Thank you, Ahmed, so much, and you might be tired of so many questions.
No worries.
I have one concern about risk assessment. Is it too biased? Is it too subjective, due to your opinion?
Yes, it's. I would say your question answers to the core of my PhD, which I found that the existing solutions and risk assessment processes are highly subjective. And I learned that by actually running many of them. When I started my PhD, I started by doing risk assessment. And the reliance on experts, I didn't like. I'm an engineer guy. I'm an engineer. I like systems. I focus on systems. I like reliable results. And when we used to do risk assessment differently, different results come, which is good. I'm not saying it's bad, but it's not repeatable. And it gives the bias of the assessor. And now you're not always have the ability to have different assessors. So if you have one assessor, you're stuck with their bias. That's why I went with my direction, which is semi-automating the risk assessment processes by encoding knowledge, what is already known, what is factual, encoded into information that can be used for risk assessment. For instance, everyone knows GPS spoofing is possible. You don't need to ask an expert about that. You can use this information within an automated way so that if you have a GPS, you immediately know you have a GPS spoofing risk that has this specific requirement to it. Doing this in an automated way for a long period of time, you will generate a knowledge graph that you don't really need experts to always tell you new things. You will always need experts. This is not something that you can replace, but not for everything, only for new things. So now my approach is being adopted in my current project called Certify for cybersecurity certification in EU, which we encode information so that when you run a risk assessment, you don't need to run it again with the same amount of information, same scope, same threats. You only add in new information that you need expert with. But previous information, you just run the risk assessment previously. So this is something that we are currently working on. So risk assessment can be made better, but you will always need human input for new attacks, new systems, and everything.
Thank you so much. And I have one more short, and I will finish with that. You show us a very nice slide with AIS victims and AIS attackers.
Yes.
Is there somebody in between who is responsible for AIS, if there is such a body, AIS messages? Who can be, let's say, defender for AIS attackers?
Yeah, that's a good question. And this attack that I mentioned, which is the covered channel, I discovered 2 points that can be used to detect such attacks, which is usually the VTS, the Visual Traffic Services. They are in the network, then they can monitor all of the environment of their own. Because someone to actually get into the AIS and transmit, they need a license, I see at least in Norway. So it's very easy to detect that someone is actually transmitting. So if you're a vessel traffic service, you can detect a new transmission, and then you can address it properly. But the messages are encrypted. So it's very hard to see that there's an actual attack running because they are all encrypted. But you can detect that there's a new transmission. illegal transmission. On the vessel itself, to detect that the attack happens, you need intrusion detection as well as endpoint security. And from my experience, ECDISs don't have that. So this is something that needs to be worked on. Some companies have, others don't.
Thank you so much. Thank you so much.
Welcome.
So, as I understand, we don't have more questions, or do you have?
No, I think that Ahmed deserves a round of applause for his
Yeah.
Thank you so much.
So thank you so much, and bye-bye.
Have a good day, everyone.
Thank you.
Thank
Bye-bye.
you. You too.
Bye.
Ciao.
Thank you.
Bye.
Thank you.